By now you should be fairly familiar with the controls of the various milling machines and the actual capabilities of the milling machines. But there are a few other procedures you must follow each time you operate the milling machine. I'd like to go through these procedures in this demonstration, and then we'll do some actual machining. First of all, remember when you come up to the mill, be sure that you check it and it's properly lubricated. We've already done that in this tape here, so we won't go through that part on this, in this demonstration. Next, we must go through and square the spindle. Be sure the spindle is square with the table. Remember, we can use a square for that. We'll drop the table down here a little bit. Okay, we'll check it. Just look in here, or you can use a shim. Okay, looks like it's square on that side. And it's also square on this side. Now for very precision work, if you had to be very accurate or wanted to check this out closer, you could use an indicator. And you could sweep the table. Here we'll just mount this is just a piece of 5/16 cold rolled steel. It's just bent off one side. Mount that in the spindle. And we'll mount our indicator to that. I'll have to raise our table up here a little bit. Lower our spindle. Okay, now what we want our spindle about in the center of the table. As far as back and forth this way. Get your spindle in the center of the table. In case you have to make any adjustments, it will equal out on both sides then. We'll move our spindle over. Approximately in the center. And we want about, probably 10 thousandths travel is sufficient, 15, 20 thousandths. This isn't critical. Then we'll set a 0 on the indicator. Then it's just a matter of putting the spindle in neutral and sweeping the table. Set the 0. Okay, it's off about 2 thousandths. And this distance being off 2 thousandths, for our machining operation here, this will be plenty close enough. Remember, 2 thousandths in this distance, it would be that percentage of the piece in a narrower part. In other words, we're going to be machining a 3-inch part. Of course, if we have 2 thousandths in this width of the table, it won't be near 2 thousandths on the workpiece itself. Once again, we'll check it this way, all the way around. Be sure we're on 0. Okay, and we are on 0 all the way around. So our spindle is square with the table. It is important that you check this each time you use the mill, because you don't know what the student did before you. He may have tilted the head and then just brought it back to the 0 points here, which are fairly close, at least close enough you couldn't see it with your eye, just looking at it, but yet maybe not close enough for machining the tolerance you want to hold. So be sure that you check this before doing any milling operation. We'll leave the indicator in a minute. We're going to have to indicate the vise in next. Now to indicate the vise in, usually want to keep the vise about in the middle of the table. We just use just a T-slot, nut, the stud, and the nut itself, hold down nut. One on each side here, and just snug them up. Now I'm going to tighten one hold down, or tighten a hold down on one side. It doesn't make any difference. We can tighten this one, or we could tighten this one here. It won't matter. I'll tighten this one here on the back side. I'm going to reposition my indicator so I can get at the solid jaw of the vise. Now note here, we are indicating on the solid jaw here. I always indicate a vise in with the indicator against the solid jaw, not the movable jaw. Sure they're on the solid jaw. Now I'll put, we'll have to put about 20 thousandths travel on the indicator, but we want to be sure that we start our indicator on the end that we have tightened down. Okay. Put about 20 thousandths travel on it. Just for a little over 20, 25, that won't matter. Now the reason that we start on the end we've tightened down is because that's our pivot point. This end here won't move as far as this end over here. So we'll be able to set a 0 point here, move the indicator down to this corner over here, and move our vise, and we'll have our vise very close to being indicated in. And we may be off 3, 4, maybe 5 thousandths because of our pivot point is actually over, about 2 inches from the movable jaw. But it's closer to this point than is this point. Therefore, this point on the vise will move further. We'll demonstrate that, and I think you can see how this actually works. But remember, you start your indicator on the end of the jaw closest to your pivot point. Okay, we've got about, it's off about 24 thousandths. Now we'll just really tap this end of it here, bring it around. We'll bring it right to 0. And we can expect it'll probably be off 4 or 5 thousandths. Yes, we'll have to do this one more time, but usually twice over, then we've got it. And run it back down the other end. All right, we're about 5 thousandths off. Reset the 0, and go through the same procedure over again. Run it down, and we'll move the vise. Now, tighten the other hole down. Make sure you have them tightened securely. And then go through and check it one more time. Run the indicator across one more time. Be sure that the vise didn't move when you tighten the hold downs down. And it reads 0 now on both ends. Now we can remove our indicator. Careful when you're using an indicator. This is a precision tool. Careful that you don't drop it. Handle an indicator with care. Now to do our milling operation today, I'm going to be using a 1-inch cutter. This is a 1-inch 4-flute cutter. It's an end mill. We'll be using this cutter. Now let's take a look at our graphics, and I'll show you the job we're going to be doing, and we'll figure out the RPM and the feed rate for this particular cutter and the material that we'll be using. The piece that we're going to be machining today is just a Allen wrench block here. We're going to machine or do the milling operation on it. We'll have to mill it the length. We'll start out with a piece of 3-inch by 1-inch aluminum. We're going to have to cut this off slightly more than 3.5 inches. Then we'll mill both these sides here off, and over here we're going to have to mill this step and this step in there. Now, we of course won't have to mill this here because it is a 1-inch piece of stock by 3 inches. So these dimensions are already held for us. We'll refer back to this later as we're machining the block itself. Now, to figure out our RPM, we use our formula. RPM equals 4 times the cutting speed divided by the diameter. Okay, now here on the milling machine, the diameter that we're talking about is the diameter of our cutter. And you'll recall in the lathe that the diameter was the diameter of the workpiece. Here, it's the diameter of the cutter. The cutting speed, in our shop here, we use 300 for the cutting speed of aluminum. We figure this out then. We have 4 times the cutting speed of 300 divided by the diameter of the cutter, 1 inch. This figures out to 1,200 RPM. The feed rate equals the RPM times the number of teeth times the chip per tooth. Now let's just think about that for a minute. I think that makes sense here. The chip per tooth, amount of stock you can take off for each tooth, times the number of teeth, and that'll give you the amount of stock taken off for each revolution, and we multiply that times the number of revolutions, or the RPM, and that'll give us our feed rate. So in this case, then, we have number of RPM, 1,200, times the number of teeth, which is 4, times the chip per tooth, in this case, 2,000. That'll give us our feed. And we figure this all out, and we come up with 9.6 inches per minute. Now, I'm going to use a 2,000th chip per tooth. Now, some of the charts here in the shop call for a little bit more than that. In this particular setup, I'm going to use a 2,000th due to the type of machine that I'm using. This will work quite well. On larger machines, your heavy-duty machines, you may want to go a little more than that. But like I say, in this case, I'm going to use 2,000th chip per tooth. Now, you want to be sure that you do use at least 1 or 2,000 so that you're not rubbing the cutter, but you are taking a chip, and that, of course, you don't take too much so that your table begins to jump or your piece comes loose or you have problems with it. In this illustration, we see the cutter up here and the workpiece down here. What we're going to show you is the different types or different methods of milling. This is called up milling or conventional milling. Notice the cutter is turning in this direction, comes around, and it is slicing into the workpiece like this. Workpiece is moving this way. The cutter then digs in here. Each tooth comes by and takes the chip out of here. Now, is pushing any slack in the lead screw or any backlash is pushed against the cutter, and the piece is pushed in as far this way as it can. On this illustration, it's called down milling or climb milling. The workpiece, again, is moving in this direction. The cutter now is turning this way. Now, each tooth comes by, digs in here, and pulls the chip out of there. Now, what this does, it'll actually pull the workpiece into the cutter. So, normally, we don't use this here method of milling. We'll do up milling or conventional milling to keep the slack out this way so that it won't dig into the cutter and chip the tooth. Now, in a shop where you had a new machine or a machine with anti-backlash, then you could use down milling or climb milling. It is somewhat more rigid and sometimes use a better cut. However, in our machines, they're older machines, and you'll run into this out in the industry also. Some of your machines will be older and not have an anti-backlash lead screw. And if this is the case, you must do conventional milling. Otherwise, it will pull it down into the workpiece. Very often, it will wreck your workpiece, and it'll break at least one or two, possibly all the teeth out of the cutter. So stick with the conventional or up milling method. Now occasionally you may want to climb mill for a finish. We get a little bit better finish with climb milling. Now if we do this, remove all the stock except for about 5 thousandths, no more than 10 thousandths, and then you can climb mill across and it'll give you a little bit better surface finish. Now we're ready to mount our stock in the vise and machine it. We're going to use a piece of aluminum here. Remember we said we cut it off. It was a piece of 3 inches by 1 inch. Okay, and we cut it off so it is slightly more than 3.5 inches long. Well, we got about 3 11/16. Be sure that before you put it in the vise, you run a file along all the corners here. You don't have any burrs on it, causing it to lift up in one spot. I'm going to mount the vise, or mount the workpiece on 2 parallels. Sure you don't have any chips in here, in your vise itself. Make sure the parallels are clean. I'll set the parallels at the bottom of the vise here, and inside the jaws. The reason for this is when I bring my cutter down, I'm going to come down here, I'm going to slab mill this. I don't want to hit these parallels with the cutter itself. Now I'm going to mount the workpiece, and I'll let it stick out here about 1/4 inch. And we'll tighten the vise up. Make sure that you tighten the vise quite securely so the piece is held solid. And just to be on the safe side here, take your hammer, just wrap that down so you're sure that you're solid against the parallels themselves. Now we'll mount our cutter. We're going to have to change collets, and we had a 5/16 collet in there for indicating. So now we have a 1 inch cutter, has a 3/4 inch shank here. We want to be sure to have the proper collet for the cutter that we're going to be using. Now we'll have to set our RPM. Remember, on the Bridgeport mill here, it's a variable speed head. The motor must be running in order to change the RPM. First of all, we'll jog the spindle to be sure we're going in the right direction. Okay, we are going in the right direction. So turn it on, increase the RPM. We'll run it. I'm going to run it about 1,000. We had a 1,200 RPM here. We'll run just slightly less than that, 1,100 or 1,000. It's not all that critical. We like to run just a little bit less than the recommended speeds. It saves on our cutters a little bit. We'll move the workpiece towards the cutter itself. Lower the spindle so that the end of the cutter is just below the bottom of the workpiece. And lock the spindle. I'm going to move over here near this edge. Well, I'll start my milling. I'm going to move up and touch off, and then I'll mill across it. Now I'm going to be doing conventional milling here. We'll stop the cutter here. We'll see, as we had talked about, the rotation of the cutter is in this direction here, and we'll actually slice the chips off here, and we'll push the table this way then. We'll push it towards the back of the machine. If there were any slack in this lead screw, it would push it that way, and we would be doing conventional milling. When I get back to the other side here, I'll probably take a 5/1000 cut and come back across it to get or climb mill back to get a better finish. Once again, we'll turn it on, turn the spindle on, move our workpiece down until it just touches the cutter. It's just now touched. Move off to this side. Now I'm going to take about I'll take a 40/1000 cut. That should be enough to clean that end up. And we're just going to clean this end up. Then we'll turn the workpiece around and we'll machine off the other end and hold our tolerance or hold our dimensions. We'll set our dials. I'm going to set this dial on 0. Now I'll move it 40/1000. 10, 20, 30, 40/1000, and then lock the table. If you don't lock the table will start to jump on you. If this starts, first thing you want to check is be sure that your table is locked. Now we're cutting aluminum. I'm going to use some kerosene here. This is what we use for cutting oil on here. When we're cutting aluminum, aluminum has a tendency to gum up on the cutting edges. And the kerosene is a very thin lubricant, and it does get right in on the cutting edges themselves. And we have to use hand feed because we're moving our table this way for this operation, moving it back and forth with our cross slide here, and we don't have any automatic feed, so we'll just use hand feed on this. Release to be sure the table locks are released, and we'll machine across it. We've cleaned up the complete surface here with the 40/1000s we took off. We have a fairly good finish there. We could leave this. I'm going to just take another 5/1000s and climb mill back across there. Release the table lock, move it 5/1000s, and lock the table once again. Remember, when you're climb milling, a 5/1000s finish cut is the most we should take. Once again, a little bit of kerosene on there, and a cutter. And we'll shut the spindle off. Move this down out of the way, move our table down here, and we remove our stock. Again, we should take a file. Should we get the burrs off here? Now we had the block sitting in here like this, just like in this fashion here. When we turn it around, it's always a good to just turn the piece this way. Now the reason for this is we keep this side then right against the this side right here. We keep this right against the solid jaw, the same side for both edges. This will help keep the workpiece square. Flip the piece over, mount it back in here. Now I'm going to take a steel rule and just check and make sure that I have at least 3.5 inches. Have the piece sticking out so I'll be able to get to the 3.5 inch mark on the workpiece. Okay, we'll make it right there. It'll be fine. And tighten it up. And wrap it here with the hammer a little bit. Be sure that you're tight against your parallels. Again, usually this isn't too critical, but if we were having to machine this thing perfectly square, we'd want to get that down solid against those parallels. And then tighten the vise securely once again. Now we're ready to take our mill the other end off here to size. We'll take a look at our print once again and check our dimensions. Don't always be sure you go back and check your dimensions a second time so you don't mill to the wrong dimension. Okay, now the dimension we're going to mill to is this 3.5 inches here, 3.5 inches. We just machined one surface off. We'll come through now and we'll finish machining this other surface off. Once again, same procedure as in the first side we machined. Bring the cutter up and touch off. Check your parallels, be sure that they're clear from the workpiece here, and turn the spindle on. Once again, just jog it, be sure you're going in the right direction. A little kerosene on the workpiece. And we'll touch off here. Now I'm just going to move it about 30 thousandths just to give me a reference point so I have a place to measure from. Move 10, 20, 30 thousandths, this would be enough. I'll lock the table. I wouldn't have to machine all the way across, but this is a short enough distance. It's just as easy to machine all the way across. And then we'll check the distance we are, and we'll move our table accordingly. Make sure you wait till the cutter stops before you put your hand in there at all. And we'll use a 3 to 4 inch micrometer to check this distance here. Okay, I've got a reading of 654 thousandths. 654 and a half, 655 thousandths on that. Okay, that means we have about 155 thousandths to go. It's a good idea here to check this in a couple of spots. Be sure that you're parallel the first side. Okay, we got 153, 154. We're within a thousandths here. So that gives us 150 thousandths to take off yet. I'll move the cutter back across here. Release the table. Now, we should reset these dials now, or we should set our dial on 0. Set on 0. And I'm going to move it. Oh, we'll leave 15 thousandths for a finish cut, and we'll check it again and take the 15th. Then we'll take that 15 thousandths off. So I'll move it 100, 135 thousandths. Now I'm going to lock the table. Notice here, be sure that your cutter is clear of your workpiece. Don't get too close here before you turn it on, so that the cutter would gouge right into the workpiece. Give yourself a half, 3/4 of an inch clearance on that anyway. Notice, again, our cutting, we cut towards the solid jaw here. It's very important that you machine towards the solid jaw. Much more rigid than the movable jaw. Kerosene on there. And be sure to check it once again. We know that we've got our 15 thousandths left to come off, or whatever we have left. All right, shows here we have 3 inches 517 thousandths. Well, we lost 2 thousandths in there. That heavy cut. Sometimes this will do this. What I'm going to do, I'm going to come back across, take a 10 thousandths finish cut, or and now probably leave 7 thousandths in for the final cut to climb mill across. This is not unusual to lose a thousandths or two. Do the heavy cut here. Main thing is that you take another cut, a light cut, and find out exactly where the cutter is in relationship to the piece. Move the table down. I'll move it 10 thousandths. Cutting oil on it. Three inches 509 thousandths. 3 inches 508 thousandths. So I'll move it in 8.5 thousandths. And we'll take one final check on that before we take it out of the vise itself here. Now we have 3 inches 501 thousandths. That's plenty close enough for this job here. Now we're ready to machine our steps we've got to put in here. Now it's a good idea when we machine these steps to put layout lines on here. Now we're going to use our dial here. We'll use a micrometer to machine these right to size, but it's a good idea to put layout lines on there for reference. I'm going to take it out of the vise, put a little dicum on it, and actually lay those lines out. Put the dicum on the workpiece here. We'll go take a look at our print while this is drying and check, once again, check our dimensions. Be sure that we have the proper dimensions before starting to lay this out. Okay, the first step we're going to mill here will be this bottom step. Notice we're going to have to hold the 2-inch dimension up here from the back edge here, and we'll also hold the 1/4 inch deep. When we finish that, then we'll hold the 1-inch dimension and 1/25 deep. Now for laying this out, I'm going to lay out a 2-inch line and a 1-inch line. The other ones here, I'll just use the dial on the machine itself to machine those. Okay, first of all, a 2-inch dimension. We'll set our combination square at 2 inches. Hold it on the back side here. Just make a mark there. Just lay out these lines here. If you want, you can set it over the end here and scribe that line all the way across. Like that. Now we'll set our square once again. 1 inch. Make a mark. Now we have it laid out properly. Now we'll put it back in the vise and mill the steps. So again, be sure you don't have any burrs in here or any chips. Now be sure that you check to see that you have enough height on the workpiece here. Notice here with these parallels, we're going to be awfully close here. The distance here that we have to move down, just measure this, we would just barely make that. Our cutter would be it's just slightly more than 1/4 inch. It would just barely make this. Our cutter would be so close to this, it would be actually too close here. We don't want our cutter to touch the vise itself. So I'm going to change these parallels and just lift this up a little bit. Put in another set of parallels. So again, check them. Make sure there's no burrs, no chips. And we'll tighten the vise down. And now we're ready to machine. Now for this here operation, I'm going to start over in this corner. All right, if I start in this corner, I'll be machining against the solid jaw once again, and I'll be conventional milling. If I were to start in this corner, the cutter would come around here like this, and it would be doing climb milling. We don't want to run it across like this. It would be climb milling. So we'll start over on this side and conventional mill. We'll go this way and mill against the solid jaw. Now I'm going to lower the cutter down here. First of all, be sure that your slack in your table is going up. And you can set that right at 0. And turn the handle around, put it in backwards so that you don't bump the handle and dig the cutter into the workpiece. Now I'm going to move the handle with the head down here and leave it out away from the layout line a little bit here. Now I'll turn the spindle on. Just going to go down just till it touches the surface. And then I'm going to clamp or lock the spindle. Now you could have locked the spindle and brought the table up and then reset the dial. Either method is acceptable. I stayed about 1/8 of an inch away from my layout line. We could actually get a little bit closer than that. I'll move it in another, I'll move it in 60 thousandths here or so. Now I'm going to set a 0 down here also. I'll try to keep, when you're machining, it's a good idea to keep the slack going with the numbers here. In this particular case, it seems it's working out good with the dial turning this way. We want to machine against the solid jaw. And we want to do conventional machining, so we're going against the numbers. But the main thing is here that you realize that, set your 0, and we'll just go and move we'll make a roughing cut, and then we'll move our table out whatever we have to. We've got to raise our table up. We had a 250 thousandths cut. Remember, we touched off here, so I imagine we probably took off 1 or 2 thousandths there already. So we're going to rough this down to begin with. One turn is 100 thousandths. I'll take off 100, 200 thousandths. We'll take a cut here and measure and see where we're at. Set our automatic feed. And start out right here. Just slightly less than 10 inches a minute. Remember, we had a 9.6 inches per minute cut. Be sure that your table is locked, cross slide here so that it can't dig in, and that this here lock on the table back and forth is released. Put some kerosene on the workpiece, on the cutter, and engage our power feed. Okay, now we'll check the dimensions, we'll find out exactly where we're at, and then we'll go back and finish the workpiece. I'm going to move that about 85 or 84 thousandths, and I'm going to come back then and machine the last 5 thousandths off climb milling. 10, 20, 30, 40, 50, 60, 70, 80, 83 thousandths. I'm going to lock our table once again. Now I'm going to use a depth mic to check the depth of the step here itself. Sure that the top surface here is clean. Just till we touch. I have 206 thousandths. Now I want to remember, when you're using a depth mic, it reads, the barrel here reads backwards as from an outside mic. So be sure that we watch for that. We have 206 thousandths. We have another 44 thousandths to go. I'll raise the table about 40 thousandths. And we're ready to take our next cut. Okay, we have just a little bit less than 10 thousandths to go in this direction. Okay, less than 10 thousandths here on the 2-inch dimension. And we have about just slightly more than 5 thousandths to go on the depth. So we'll take our finished pass now. Give it up 5 thousandths. And we'll move it out 10. Check it one more time before you make any adjustments. Okay, we've got about 2 inches and 2 thousandths. Okay, and this is well within our tolerance here for this particular part. If we had to be right in there, we just move it another 2 thousandths, take another pass. Now, remember, this step here was only 1/8 of an inch deep. So now I'm going to drop the table down 1/8 inch. Okay, reset a 0. Bring the table down 1 complete turn plus another 25. Go beyond that and then come back to it so that you have the slack going in the same direction. You should always keep your table slack with the table coming up. Now we're ready to machine our second step. Turn our spindle on once again. And we'll check our dimensions here. Remember, we should have about 50 thousandths to take off here yet. And we have 51 thousandths. Okay, we've only got about 3 thousandths left here. We won't take another pass on this. We'll wait and we'll take this off when we climb it across the last time. We had 50 thousandths to go on the 1-inch dimension, so we'll move this out 10, 20, 30, 40, 45 thousandths. We'll lock our spindle once again and make our next pass. got about 7. And we've also got about 7 thousandths on this side. Now we don't have to check the depth of the step. We didn't take anything off that. So we'll just reset this now. Get 7 thousandths off. Mark the table. Raise our knee. 3 thousandths. And take our finish pass. Remember to check it one final time before taking it out of the machine, just in case you might have messed up here and misread your mic. So you don't have stock to come off, and you have to put it back in the machine once again. Okay, we have 1 inch, about a 1/2 thousandths here. Also 1 inch and about a 1/2 thousandths. Check our depth once again. We're at 125 thousandths. So we have a finished workpiece. In summary then, remember when we're using the milling machine, first of all, clean the table all off, make sure that everything is clean, the vise is all clean. Be sure that you check the spindle for squareness. Now this can be done with just a square, or for very precision work, you'll want to put the indicator in and sweep the table. Be sure that you're running your cutter at the proper RPM and the proper feed rate. Make sure that whenever possible we conventional mill and we climb mill only for finish milling. You should have no problem running the mill. Go ahead and we'll machine a block similar or just like this one here for your first operation.
The preceding materials are copyrighted by the District 1 Technical Institute, Eau Claire, Wisconsin. Duplication of these materials is strictly prohibited. Infringement may result in penalties ranging from fine to imprisonment.